Oh, that's a great movie. That's why I put stuff up like that to see if people notice. Yeah, I'm a big fan of all three of them, actually. Yeah, most of the time I put this stuff up to amuse myself. Nobody gets it, but that's okay. I figure that's just because I'm old. All right. So first thing we're going to talk about is something that they call a reference angle. Okay. So it says find the measure of each angle as a positive measure, a negative measure, and an angle measure that is greater than 360. All right, so what we've got here, see the little 45 and the little 60-degree angles here? These are what's known as reference angles. A reference angle is the shortest distance in terms of an angle measure to get back to the x-axis. So notice here it's above the x-axis, but it's still 45. And over here, on the other side, it's 60, it's below the x-axis, but it's still looked at as a positive. So what do they mean by a positive angle measure, a negative angle measure, and then, of course, a measure that's greater than 360? Okay, so we know with circles, 360 degrees is all the way around the circle, right? Okay, so when they measure angles, they start at the positive x-axis. So this would be 0 degrees right here. Okay? And then we always talk about this being a 90-degree angle, right? So that must mean this guy up here is 90 degrees. Okay? And then over here, this is 180. And probably in algebra class or somewhere along the line, they mentioned that 180 is the degree measure of a flat line. And our flat line in this case is going to be the x-axis. Okay, and then the next one, this is going to be another right angle. So I've got 180 and I add 90 to it. This is 270. Okay, and then again, if I add another 90, 270 and 90 is 360, and I'm back to where I started. Okay, and if you were drawing a circle on this grid, that's exactly what would happen. You'd go all the way around and you'd be at 360 degrees. So they measure these guys starting at the x-axis and going this way is positive. Okay? And if you go this way, it's negative. So positive is what they call counterclockwise, and negative is what they call clockwise, which unfortunately doesn't make a lot of sense to most people anymore because nobody knows an analog clock. They'll use digital clocks or their phones or something like that. But those are the two measurements we need to go with. So when they're talking about the positive angle, what we mean is if we start here, what is this angle measure? Okay, so if it stopped at the y-axis, we know it would be 90, but it's more than 90, isn't it? The way you can figure that out is you say, I've got 180, I got a reference angle of 45, so I do 180 minus 45. So I got 180 and then minus 45. So this angle here is 135 degrees. And after a while, you start getting a vibe for these things. So if we go to here, that is 135. Now if we go the other direction, this is going to be a negative angle. Right? So this is the negative one we're talking about. So think of it this way. If I'm going this direction, this is negative 90 to there. If I go halfway around, this is negative 180. To get to this guy right here, I need to go an additional 45. All right. So that would be 180 and then plus 45 more. So that's going to be 225 degrees. And we're going in a negative direction, so they put the minus sign in front of it. So that's minus 225. Okay, so an angle measure that's greater than 360. Well, 360 is one trip around the axis, or one trip around the circle. Okay. So for this first angle here, they say, okay, greater than 360. I mean, okay, I know this is 135, right? So we're here at 135. If I go all the way around again, I can do that just by adding 360. So then the measure that's greater than 360, you just take the angle that we've got, which is 135, and we add 360 to it. So that's 495. So if I stop here and do one extra trip around, then this angle is going to be 495. So that's this guy right here. Okay, so that means take a trip around, go another 135 degrees, and we're at that exact point. These are what's known as coterminal angles, another fancy term they have for this stuff. And what coterminal means is we end up at the same spot on the Ferris wheel by just going all the way around and come back to the same spot. And if we're going in one direction, counterclockwise in this case, we just keep adding 360. So if I added another 360 to 495, we would yet still be in the same spot, even though the angle measure would be even bigger. Or we could subtract 360 if we're looking for negative ones. Subtracting 360 means we're just going around the Ferris wheel in the opposite direction. Okay? Does that make sense? Okay, well let's do the next one. So again, the reference angle is the quickest way back to the x-axis. So notice that this guy is 6 degrees below the x-axis on the left-hand side. So if we're doing the positive angle, we start here, we come up to here, that's 90, right? We come to here, that's 180, and then we have to add another 60 to that, right? So we do 180 plus another 60 is 240. So the positive angle in this case is going to be 240. That's going to be right there. The negative angle, if this is 60 and this is 90, then this guy's 30, right? So in this case, we're going in the negative direction. We go negative 90 plus another 30. So this guy's going to be minus 120. Now, notice something about this. When the positive and the negative, so we go around, it's 240 degrees positive, or it's 120 degrees negative, and we end up at the same spot, don't we? If the minus sign wasn't there, notice that 240 and 120 is 360. So it's just different sides of the circle. You're coming into a certain angle, going one direction, we're going to have 240 going the other direction, we have negative 120. So we cover the entire circle. And again, if we wanted to have a number bigger than 360, we could take the 240 and add 360 to it. And that would give us an angle measure that is bigger than 360, but still in the same place. So we do 360 plus 240. So that's a 600 degree angle. Okay. Now you could do the same thing going the other way. If we do minus 120 and we add 360 to that, guess what you're going to get? You get the 240, don't you? And then again, if you wanted to have something bigger than 360, you would add the 360 again, and we'd be back to 600. Okay? So like I said, you guys will get used to this as we kind of go along with it. All right. All right, so this one says, Find the measure of an angle in standard position for each reference angle. All right, so this says it's 15 degrees in quadrant 2. Remember your quadrants? We go around this way, so there's 1, there's 2, there's 3, and there's 4. So if we're in quadrant 2, and this is 15 degrees, then if we start here, let's switch up colors here. We start here and go to here. So obviously this is 90, and halfway around is 180, but we're not going all the way around. We're going to back up 15 degrees, right? So if you take 180 and subtract off 15, we get 165. So this angle here would be 165. Okay? So that's 23. So this one says 75 degrees in quadrant 4. So that'd be this guy here is 75. Oh yeah? Cool. So was that like a geometry class, or what was that? Because I think they do some of this in geometry. Okay, yeah, that makes sense then. All right, so again, if we want a positive value for this guy, we know that if we go all the way around, that would be 360. But we're not going all the way around, are we? Because there's still 75% left to go. Okay, so if we take 360 and subtract off 75, that's going to give us our guy. So let's go ahead and do that. So we do 360 minus 75. So this angle here would be 285. Okay. Obviously, we don't have room for, this is 24. Obviously, we don't have room for 25 and 26. So we duplicate the slide and clean it up a little bit, and we can use it for that. Okay. I'll go ahead and clean up a little bit. All right, so this says 8 degrees into quadrant 3. All right, so there we go. So again, quadrant 3 is down here. And we're 8 degrees into it. Not drawing the scale, obviously. We'll call this 8 degrees. All right. So what is the measure of this guy? So again, we start at the positive x-axis. She's doing good? All right. Yeah. Yeah, I've been there, buddy. You know what caused mine? A frickin' pizza. Guess who hasn't had a pizza since September? So I hear you. All right, man, I'm glad she's doing good. Yeah, too much salt in that stuff. All right, so again, for this guy, we start here at the positive axis. We go to here, that's 90. We go to here, that's 180. And we have to go just a little bit further, another 8 degrees. So the angle of this the measure of this angle, excuse me, is going to be 188. Okay, so 188 degrees. And this one, 56 degrees into quadrant 1. Guess what? Our angle measures 56 degrees. Because quadrant 1 is where we start. Okay? All right, so let's check out some more. So this says, sketch each angle in standard position. Okay, so 27 is 30 degrees. So if we know this is 0 and this is 90, then it'd be like cutting this square into 3 equal sections as far as the angles. So 30 degrees would be about right here. Okay, so this is 30 degrees. So the next one is minus 45. Now, for 45, we move in the opposite direction, and 45 is halfway between 0 and negative 90. So this is 0, and this would be negative 90 going in this direction. So this would be 45, negative. Okay, so that's that guy. Just trying to color code it here for you a little bit. All right, so let's try another one here. So this one says negative 210. So we start here. There's negative 90. Negative 180. We need to go 30 degrees more to get to this guy. So it's going to be minus 210. Okay, so there's that one. And then finally we've got 130. So again, this is a positive one. If we go to here, that's 90. And we have to go an additional 40 degrees, right? So that'd be about in here someplace. So then this would be positive 130. Okay? So once again, if you're going in the positive direction, we go what's known as clockwise. And think of it the same way that's how the quadrants go too. We start with 1, we go counterclockwise to 2, and then to 3, and then finally over to 4. Okay. So the positive ones are going to go that way, and the negative ones are going to go in the other direction. So those are going to go this way. Okay. Questions? All right. Oh yeah, okay. So now let's talk about something called radians. And for the most part, I got no use for radians. Okay. I could show you one thing where it's easier to use a radian than a degree. We're not going to get to that today. But we tend to think in degrees. We have a vibe for degrees, right? When you say 360, you know we've gone all the way around this thing. When you say 180, we know we've gone halfway around. When you say 2 pi over 3, you're like, wait, what? Exactly. So here's the deal. When they're talking about radians, what they're talking about is, like I say, we're used to degrees, right? If I can get this thing to right, that would be awesome. So we're used to degrees. So if we have a circle, time to laugh at my badly drawn circle, all the way around is 360 degrees. Okay, we get that. Now let's talk about the circumference of a circle. Remember, circumference is the distance around, right? So the circumference of a circle is 2 pi times the radius. Well, in this case, let's make the radius equal to 1. So that means one trip around the circle is 2 pi. And one trip around the circle is 360 degrees. Okay? So if 2 pi equals 360, 1 pi, which is half of 2, equals 180, which is half of 360. This is kind of a big deal. Will kind of save you a lot of time. Pi equals 180 degrees. Again, kind of a big deal. So now we're going to talk about, if they give you a degree measure, how you convert it into radians. You take the degree measure they give you. You divide it by 180. If they want a fraction, you can reduce the fraction, and then you stick a pi next to it. And if they ask you to calculate the answer, find an approximation, we use our calculator, but only when they ask us that. So what do I mean by that? So let's say that we have a degree measure of 60. So 60 degrees. Okay, so we take the degree measure they gave us, 60 degrees, check. We divide that by 180, so I have 60 divided by 180. Okay, reduce the fraction if you can. We can definitely divide by 10. Now I have 6 over 18, right? I can divide both those guys by 6, right? So 6 divided by 6 is 1, 18 divided by 6 is 3. So it's 1/3, and I said stick a pi next to it, 1/3 pi. Now, for some reason, they don't want to write that extra 1, so they would write this as pi over 3, okay? So pi over 3 radians equals 60 degrees. But that's how you do it. Whatever they give you, divide it by 180, stick pi next to it, reduce the fractions if you need to, or if they want to approximate it on the calculator, do that. So in this case, if we did it on the calculator, since we got it down to this point here, we would just say pi divided by 3. And that's 1.04 radians. Okay? That's pretty much it. So there's two ways to measure the same thing. Now, if you go from radians to degrees, that's even easier. So it says turn pi into 180. And once again, pi equals 180. Kind of a big deal. Too subtle? And then plug it into your calculator. Again, if we had something like, let's make a fancy one this time. 2 pi over 3. Okay, what does that equal in degrees? Pi equals 180. So this would be 2 times 180 divided by 3. Calculator City, here we come. Move this back over, come on. There we go. So we do 2 times 180. That's 360. And then divide by 3 is 120. So 2 pi over 3 is 120 degrees. Okay? So that's how you convert radians to degrees. Pretty easy. Wherever you see pi, pop in a 180 and we're good to go. All right? So now here's the thing. If you have a fancy calculator, I don't know if you do or if you don't, you'll see a button on there that says mode. One of the modes you can put your calculator in is radian modes. I'm not telling you how to live your life, but if for me, do not ever, did I mention ever? Ever put your calculator in radian mode. Because first of all, it's too easy to convert from degrees to radians anyway, or radians to degrees. It's easy to convert, as you've seen. And secondly, what happens is if you put your calculator into radian mode, you'll forget that you put it into radian mode. And then when you try to do normal calculations, you are going to get some serious weirdness, and you're not going to know why. Been there, done that. Don't do it. Okay? Always leave your calculator in degree mode. Words of the wise. And if you have a calculator that doesn't have a mode like that, then you don't even have to worry about it. And like you guys know, I'm not a big proponent on having really fancy calculators. I think they're overpriced and they have a whole bunch of stuff that you're never going to even look at. All right. So let's check out a couple of these problems. Get this thing to move. That would be awesome. Come on. Here we go. All right. So this says convert each angle to radians and round to the nearest hundredth. All right, so let's go back to our instructions for a second. So we're going to radians. Convert to radians, they take the measure they gave you and divide it by 180. Okay? So we got 148, we're going to divide that by 180. And then we stick a pi next to it. Now normally we would go ahead and reduce the fraction, but since they want us to calculate and round to the nearest hundredth, we can just do this on our calculator. So it's going to go like this. All right, so clear it out. So we're going to do 148 divided by 180. So 8.222, and then we take that times pi. So to the nearest hundredth, that'd be 2.58. So that's radians. Over here we got 20. Divide him by 180, stick a pi next to it, calculate. So in this one, we say, okay, we've got 20. Divide him by 180. You get put ones, and then take that times pi. So to the nearest hundredth to be about it's up here, 0.35. And again, these are radians. Okay. Now this one says to convert each measure to degrees. What do we say pi equals? Kind of a big deal. Kind of said it a whole bunch. Pi equals what? How many degrees? This is where you answer. 180. Beautiful. I know you meant 180. We'll call that a typo, but that's okay. So again, all I have to do, and matter of fact, I already did this one. So 2 pi over 3 is the same as saying 2 times 180 over 3, which we already figured out was 120. I did that one by accident. All right, next one's 5 pi over 6. So 5, instead of pi, call it 180. So 180, and then divided by 6. Calculator city. So we go clear it out. We go 5 times 180, looks like 900. Divide that by 6. So our answer is 150 degrees. It's just that easy. Pi just becomes 180, and then use your calculator. Questions? No thanks. I like it. All right, next one. So it says select all statements that show the correct relationship between degree measures and radians. Okay, so let's do this. It's easy to convert from radians to degrees, so we're going to turn these guys into 180s, right? So this will be 180 over 6. All right. So back at our calculator, and we say 180 divided by 6. That's 30, not 60. Not that guy. Next one says 3 pi over 4. So this would be 3 times 180 divided by 4. Okay, calculator city. We're going to do 3 times 180 divided by 4. 135, not 240. Thanks for playing. All right, next guy. Pi over 112. So that's just going to be 180 divided by 12. All right. Let's try try that guy. So we do 180 divided by 12 is 15. Ding, 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 ding. That guy works. Okay, next one. We'll move him straight out here so we've got some room. So this is going to be 180 divided by 3, right? Okay, so 180 divided by 3. So 180 divided by 3 is 60. And thanks for playing. No. All right, next guy. This will be 10 times 180 over 9. All right, so let's go ahead and do that one. So we got 10 times 180 divided by 9. 200. Ding, 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 ding. That guy works. And we know that 180 is not 3 pi over 5 because 180 is pi, right? Don't have to do that one. So there's our guys. So see all we did there was anytime you saw a pi, you turned it into 180 and did your calculation. Easy peasy. All right, one more and we're out of here. All right, so this one says, what is another way to represent an angle in standard position that has a measure of 530? Okay, so 530 would be more than 360, right? So we've taken one trip around the circle, and how far do we go around again? So all we need to do here is we're going to take 530 and subtract off 360. And that's 170. Ding, 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 ding. So all we did here was just subtract it off the 360. Okay? And since they don't say check all that apply, I'm assuming that's our only answer. All right? Questions? All right, well, that's all I've got for you for today. Thank you for stopping by. No class for you guys tomorrow. That's a good thing. And we'll continue on with this next week.